actually very, very worried about that. Digital librarians are also very worried that we're accumulating content that we won't be able to interpret over time. There are lots of devices showing up on the net, and I have to say, considering the 35 years or so that I've spent with this interesting system, some devices have shown up that I really never expected would be. We used to make jokes about toaster net, and in fact, somebody did put a toaster up on the internet at one of the interop shows. You could send an SNMP packet to say how burned you wanted your toast to be. There are, in fact, high-end refrigerators with nice liquid crystal touch-sensitive displays. They're plugged in. There are picture frames that download images off the net every 24 hours. And there are telephones that really aren't telephones. They're voice-over IP computers. But I like the guy in the middle here who produced his internet-enabled surfboard. That would be popular here in Hawaii, I would think. He's from San Diego, and I'd never met him, but I have this fantasy in my head, kids sitting on the water waiting for the next big wave, thinking, if I had a laptop in my surfboard, I could be surfing the internet while I'm waiting to surf the next. So he built this thing, and he put a Wi-Fi service at the rescue shack back on the beach, and he sells this as a service. Just to underscore the fact that sensor networks are becoming more popular, I have an IPv6 6-low-pan sensor network running in my house. It's from a company called Archrock, and it's keeping track of temperature, humidity, and light levels in all the rooms of the house, especially the wine cellar. And it's designed to alarm whenever the temperature goes above 60 degrees Fahrenheit, which it did about 2 months ago. I was at Argonne National Laboratory for 3 days. My mobile went off. It was the wine cellar calling. It turned out that the temperature had gone above 60 degrees, and every 5 minutes I got this little alarm saying your wine is warming up. And unfortunately, I was away for the 3 days. My wife was in Russia on a tour of some sort, so nobody could come and turn the cooling system back on. So by the time I did get home, it was about 70 degrees in there. Fortunately, no serious damage done. But I called Archrock right away and said, hey, do you have actuators that I can run remotely in addition to just telling me I'm in trouble? I expect to see a large number of these sensor systems show up on the internet for office buildings especially, to try to do a better job of controlling environmentals and being more efficient about use of lighting and things of that sort. More and more you'll see these things happening, and eventually it'll show up in residential settings too. This is just the details of you can't read it, I'm sure, from anywhere. But these are temperatures and humidities and things like that. Other things that are happening to the internet, this is quite dramatic. 2009 should be marked as an important year in internet's history, because changes are happening of a magnitude that have not happened since the internet was first released in 1983. The first thing is motion finally towards IPv6, the 128-bit address space. 3.4 times 10 to the 38th addresses. This is a number only the Congress can appreciate. But I keep hoping that once we get this deployed, it'll last till after I'm dead, then it's somebody else's problem to worry about address space. It's very important, though, to release v6 and v4 running in parallel. So if you're in the server business, you want to run both v4 and v6. If you're on the client side, theoretically, you should be able to run one or the other. You may not necessarily have to run both. The domain name system itself is quite insecure, and so a new addition to it is called DNSSEC for Domain Name System Security, allows us to digitally sign entries in the domain name system. So when you do a lookup and you ask for a digitally signed answer, you can validate that the information you're getting is the same as it was put in to the DNS by whoever it is who is responsible for that particular domain name. The third thing which is happening is that the domain names of the internet, which have since the beginning always been expressed in the Latin characters A through Z, 0 through 9, and the hyphen, are now going to be expressible in other non-Latin character strings, so that we'll be able to use Hebrew and Arabic and Urdu and Chinese and Korean and so on. This doesn't necessarily result in a more secure system exactly, because with all these new symbols available, it may be more possible for people to become confused. A simple example is writing PayPal, P-A-Y-P-A-L. If you use a Cyrillic A instead of a Latin A, the computer thinks that's a different string than an all Latin character string, and it will assign a different code to it, and therefore, if you click on PayPal with a Cyrillic A, it will go to a different place than PayPal with a Latin A. So there are some rules that have to be introduced about what can be registered at each registry, or in fact even some rules at the protocol level that limit what kind of mixing is permitted among the scripts of the world's languages. And that is turning out to be fairly tricky. The Internet Engineering Task Force is involved in finalizing a new version of the internationalized domain names to try to minimize the potential for those hazards. But we have to do it. If you remember the statistics of where the people are on the Internet, it's very clear that for many of them, their languages are not expressible in Latin characters, and it's just not right for them to experience the Internet in anything other than, at least to have an opportunity to experience it in a language or symbol set that's comfortable for them. And a consequence of that is that there will be new top-level domains coming, not only in Latin characters, but also in characters that are expressing other languages. I mentioned cloud computing earlier, just to emphasize that this is a clear example of collaborative and cooperative enterprise. Google, to give you a concrete example, has a number of data centers around the world. Each of them contains a classified number of computers, so I'm not going to tell you how many, but it's a big number. And they interact with each other. They share information, and the reason they do that is to make sure that information that is put into any one of them, for example, your Gmail, also shows up in one or more others, so that if anything should happen, if access should go away, if the data center stops running, your information is protected and accessible continuously. So there's a huge amount of collaboration taking place within the data center complex. The thing that makes cloud computing so attractive is that it does involve a very large number of computers, and they can be dynamically allocated. So if you happen to have a computing requirement which requires a large number of processors, more than you could do with your laptop, it's not a problem for a cloud system to absorb that processing requirement or that data requirement, perform the computation, and then hand the result back. And then those assets are available to someone else. And so it's time sharing all over again on a massive scale, but it requires a substantial amount of sharing of information. Similarly, data sharing is very interesting. If you're interested in collaborating with someone, I don't know if you've ever written a joint paper and you've passed copies of the paper around to the N people who are trying to work together, it becomes very complicated to figure out who owns the most up-to-date copy. Or some poor soul is responsible for taking all of the inputs, which may be conflicting, and to integrate them into the next version. In the cloud environment, you have a copy, which everybody goes to because that's the current copy. It may be replicated for reliability, but there is one current copy. It's the one on the net. So that makes collaboration remarkably easier. In fact, I've watched groups of people talking to each other and maybe even video conferencing while they're working on a common document, making edits in real time. And once again, the ability to collaborate smoothly and easily is facilitated. However, there's a real research problem here because more than one entity is creating cloud computing systems. Google has some, Microsoft has some, Amazon has some, and others I'm sure have them as well. Nobody, as far as I know, has really sat down and said, okay, what does it mean for one cloud to talk to another? What does it mean to move data from a cloud to another cloud? What if the data has been protected in a certain environment with access controls in cloud A, and we move it to cloud B? How does cloud B know how to protect the information when it gets there? Well, this is kind of like the internet problem all over again. It's because you don't know what you can tell another cloud to do. You don't know how to pass metadata to the other cloud. It becomes a very, very interesting research problem. So if there's anybody here from the University of Hawaii, including David, looking for a dissertation topic, that's it. There are lots of other examples of collaboration, capacity sharing.